Thin layer chromatography. Introduction. Thin layer chromatography is a type of chromatography used in analytical chemistry to separate and identify compounds in a mixture. It is a fast and simple method that involves the adsorption of the compounds of a mixture onto a solid adsorbent material, typically silica gel or aluminum oxide, which is coated onto a glass or plastic plate. The plate is then placed in a solvent that will cause the compounds to move up the plate. Thin layer chromatography is a form of liquid chromatography that was first described in early 1900s by two German scientists, Dennis Garber and Martin Hench. It was later developed and improved upon by several other scientists in the decades that followed. TLC became a popular analytical technique in the 1940s and 1950s due to its simplicity, versatility, and low cost. Components of TLC. The main components of TLC include a stationary phase, a mobile phase, sample, plate, and a developing chamber. Principle of TLC. The components of the sample mixture will separate based on their relative affinity for the stationary and mobile phases. Components with high affinity for the stationary phase will move more slowly up the plate and form distinct bands. Components with low affinity for the stationary phase will move more quickly up the plate. The separated components can be visualized and analyzed using various detection methods. TLC results can provide information about the composition and purity of a sample. How does the TLC work? A schematic illustration of the working of TLC is shown here. The working of the TLC include the following steps. Preparation of the TLC plate. A thin layer of stationary phase material is applied to a glass, plastic or aluminum plate. The stationary phase can be made of silica gel, alumina or cellulose among other materials. Application of the sample. The sample mixture to be analyzed is applied to the plate as a small spot or line near the bottom of the plate. Development of the TLC plate. The TLC plate is placed in a developing chamber and the mobile phase is added to the chamber. The mobile phase is a liquid solvent that is chosen based on the nature of the sample and the desired separation. The mobile phase is allowed to flow up the plate by capillary action, carrying the components of the sample mixture with it. Separation of components. As the mobile phase moves up the plate, the components of the sample mixture will separate based on their distribution between the stationary and mobile phases. Components with a high affinity for the stationary phase will tend to remain in the stationary phase and move more slowly up the plate, while the components with a low affinity for the stationary phase will tend to remain in the mobile phase and move more quickly up the plate. Visualization and analysis of separated components. The separated components can be visualized and analyzed using various detection methods such as staining with ultraviolet light, spraying with reagents, or heating to produce specific reactions. The results of TLC can provide information about the composition and the purity of the sample and can be used for a wide range of applications in fields such as chemistry, pharmacology, biochemistry, and environmental science. Interpretation of results. The results of TLC can be interpreted based on the position, intensity, and number of separated bands on the TLC plate. The identity and purity of the components can be determined based on the RF value, which is the ratio of the distance travelled by a component to the distance travelled by the solid front. Retention factor. The retention factor in thin layer chromatography is a value that represents how far a component travels on the TLC plate relative to the solid front. It is calculated as follows. RF is equal to distance travelled by the component by distance travelled by the solvent front. The distance travelled by the component is measured from the point where the sample was applied to the TLC plate to the point where the component is first observed. The distance travelled by the solvent front is measured from the point where the sample was applied to the TLC plate to furthest point reached by the solvent. Applications of thin layer chromatography. Some of the applications of thin layer chromatography include analysis of natural products. TLC can be used to analyze the components of natural products such as herbal extracts and essential oils. Analysis of pharmaceuticals. TLC is often used to identify and quantify the active ingredients in pharmaceuticals. Analysis of food additives. TLC can be used to determine the presence and concentration of food additives in food products. Limitations of thin layer chromatography. Poor resolution. Thin layer chromatography may not provide the same level of resolution as other chromatography techniques such as gas chromatography or high performance liquid chromatography. Poor sensitivity. TLC may not be able to detect very low levels of sample components. Quantitative limitations. TLC is not well suited for precise quantification of sample components. Wrapping up. Summary of TLC. TLC is a useful technique for separating and identifying the components of a mixture. Future of TLC. TLC continues to be an important tool for many applications, and new developments in TLC are likely to emerge in the future. Final thoughts. TLC is a powerful and versatile technique that provides valuable information about the composition of a sample. Thank you.